that you're going to hear from today is called Greenlight Biosciences. They're a company out of Medford, Massachusetts, one of the hubs for biotechnology. And the COO, Chief Operating Officer of Greenlight Biosciences, started her career at Kodak here in Rochester at Kodak Research Labs. She was part of a division that called Kodak Life Sciences that was eventually spun off. And currently, if you drive down Lexington Avenue near Route 390, you'll see a DuPont facility on Lexington Avenue there. That was formerly Kodak Life Sciences. So she joined that company when she left. And then eventually, I guess it changed hands a couple times before it became DuPont. And there was an employee buyout in one of those. So she left the company and ended up joining Greenlight Biosciences. When they developed their technology enough to need a manufacturing site, she remembered the assets that we have at Eastman Business Park, and she advised her company to put the plant here instead of Boston or North Carolina, which they were thinking about originally. They have some Triangle Park assets. So Greenlight Biosciences is a really cool company. They need the utilities that we have. And they make stuff that's again, very environmentally friendly. Their first product that they're making at Eastman Business Park is a pesticide that targets a specific pest. So if you think about chemicals like Roundup, they kind of kill everything. And what they're trying to do is design products that only impact the pest itself. So this new pesticide, you and I could sprinkle it on our dinner at night and eat it, and it wouldn't bother us at all. But because of the way that it's designed, it really hurts the Colorado potato beetle, which is, as you can tell from the name, it comes out of Colorado. But apparently, there's a pretty big infestation of Colorado potato beetle in the county that's just east of us. Is that Genesee County? I don't know. I don't remember, but it does have a local application as well. So they're building a pilot plant right now, which Eric Otto will tell you about. And they have a lot of other really cool products that are, again, genetically designed to do their job. So that's Greenlight Biosciences. Another cool company that you're going to hear from is Farther Farms. Farther Farms comes out of Cornell. There's the food and ag school there. They're doing a lot of great stuff down in Ithaca and Geneva. Anyway, Farther Farms is renting about 30,000 square feet in one of our buildings, and they are using a proprietary high pressure processing system to basically preserve vegetables. So the high pressure processing system can kill all the bacteria that might cause decay in a vegetable without hurting the structure of the food. And you'll have to ask Max how they do that.
Yeah.
But anyway, their first product is French fries. So they're very popular within the park.
Oh, I bet.
Yeah, they get potatoes from local farmers, and they make French fries that can be packaged, and instead of being shipped frozen like most French fries are, they can be shipped in a baggie, basically, and no preservatives, nothing, just the potatoes themselves. One of the founders of the company is a native of India, and as you can imagine, they don't have the frozen food infrastructure that we have here. So his idea, and I guess his thesis at Cornell, was to come up with a way of shipping food around India without the requirement of having it to be frozen. And this new technology that they're implementing here at Eastman Business Park came out of that research that he did. So that was pretty cool. And then the last one that you're going to hear from is a vice president at Kodak, who has spent his career here, I want to say close to 40 years. But, a highly energetic guy, and the new product that he's in charge of building a plant to make is a light blocking material. So they're actually particles that can absorb light. And I've seen samples of it where you just take regular fabric like you might have for curtains in your house, and without the light blocking material, the light just comes right through. You know, you can almost see through the fabric itself. You put this coating on it that doesn't dramatically change the way the fabric looks or feels, and no light comes through, almost like a piece of wood or, you know, something solid. It's that good. So some of the first applications are going to be for things like hotel curtains. Like if you go to a hotel now, you've probably seen the regular fabric curtains, and then behind that, these really thick, sort of plasticky type of curtains. Those can be completely replaced. It can also be used for privacy curtains in hospitals, et cetera. But there are many other applications, like this technology can even be used to absorb infrared light and ultraviolet light. So if you're thinking about fabric that could prevent sunburns, for example, for ultraviolet, or a military application, if you don't want to be seen by infrared, put that on your clothes and suddenly you're invisible. So a lot of cool applications. And Kumar is right now building out, I think it's 240-foot long coating machine, so almost the length of a football field, to coat fabric with this new particle that was invented by Kodak. So kind of cool.
Tim,
So anyway, sorry, go ahead.
oh, no, sorry. I just wanted to, obviously we're gonna like pick the brains of all these executives and get more in depth, but I wanted to talk a little bit more about EBP and
Sure.
sort of the renaissance that it's experienced. I'm sure that COVID has put a knot in some of the plans for the public facing amenities that you guys have, but maybe you can talk a little bit about what's happened over the past few years there.
Oh, sure. Yeah. So some of the things that might be more obvious than the industrial stuff, Kodak Center, which is on West Ridge Road, 200 West Ridge Road. That building was built in the 40s and 50s for Kodak employees, for education, entertainment, and so forth. You know, if you think about the kind of campuses that Google and Apple have nowadays with all kinds of recreational opportunities, Kodak was kind of like that in the 30s, 40s, 50s, 60s, et cetera. There's that building has 2 basketball courts. It has a 2,000-seat theater. It had a bowling alley, pool hall. You could bring your pistol to work and shoot at the rifle range. I mean, it was unbelievable stuff that you wouldn't hear of today. But anyway, that building still exists. In the 2,000-seat theater, we thought, well, gosh, we should reopen this and, you know, make it available to the public. So we did that back in 2017, and we've sold hundreds of thousands of tickets so far to all kinds of entertainment, from family stuff to comedy to concerts and so forth. It did, as you said, Shannon, get a crimp put in by COVID. It had to shut down like everybody else, but we are in the process of planning for reopening in September of this year. You know, of course, that depends on what happens with COVID and state guidelines and so forth. But we kind of wanted to have a stake in the ground and plan for a certain date, just so we would know how to staff and so forth. So that does, you know, it looks fairly promising right now with the vaccine and all that. So that's one. Another thing that we did was we identified housing as an opportunity in the area. So we worked with a developer called Pathstone to turn a 9.2 acre parking lot into a 187 unit housing development. That's at the corner of Dewey and Eastman Avenue. It's located outside the park. It's basically, it used to be houses, and then we knocked down the houses to build a parking lot, and now it's houses again. So it's a much nicer application for that land, and we're working with Pastone now to build another housing complex with 257 units, I think it is, right along the edge of the Genesee River. And part of that would be enhancing the river. What's that called? There's a trail that runs along the Genesee River for biking and so forth. So it'll enhance that to make it more of public access for the river, and more housing for people. The first housing project, called Eastman Reserve, sold out immediately, and I think they have a waiting list of something like 600 people to get in there. So there's clearly a lot of demand for it. And we're working with a fish farming company that does land-based salmon farming. So it's one of those controlled environment agriculture things where it's truly organic, because you don't need the pesticides because it's not exposed to, the natural world. So they'll be producing really high quality North Atlantic salmon in that fishery, and that's also a very clean type of operation because it butts up against neighborhoods and so forth. They'll have a visitor center there, and it'll be nicely landscaped for walking around. So that whole area that's currently just 30 acres of asphalt is going to be something very attractive within, I'd say, 4 to 5 years by the time that gets developed. So those are just a couple of examples of the non-industrial side of things that we're trying to do to enhance the area that we're located in.
Great. Another question for you, Tim. Obviously, a big part of your job and the goal of EBP is to get tenants to come and locate. And I know you have some space left there. So, what kind of methods and tactics are you guys employing to try to reach out to local or even national global companies to come locate there?
Well, probably the most important thing, Shannon, was having a really clear idea in terms of the right industries for the park. When we first went more of a open tenant basis, it was almost like anyone who wants space can come in and rent it from us. Now we're being really targeted because, like, for example, a warehouse doesn't really use steam or industrial sewer or some of the key utilities that we have here. So now when I get requests for land to build a warehouse, I say, no, sorry. And it doesn't really matter what price you're willing to pay for the land. It's not a good use of it because it doesn't help offset the costs of running the utilities. So the businesses or the types of industries we're focused on are biomanufacturing, like Greenlight Biosciences, food and beverage, which need a lot of steam and chilled water in the industrial sewer. Chemical manufacturing is another big one because chemicals are, we know how to handle them, and we've done it for over 100 years on site. And then things like coating, again, putting chemicals onto a substrate to do something new. And photonics is another big one with AIM Photonics over in the old on semiconductor building. So once we've identified the industries, then we work with local entities like the Chamber or the Greater Rochester Enterprise. We work with Empire State Development in New York to identify inbound space requests that might be a good fit for the park. But we also do direct outreach to companies within those industries that we can identify as having expansion requirements. So biomanufacturing has been one that's quite interesting to us because it's an emerging industry and they really need the utilities that we have. So I attended a biomanufacturing summit in January of 2020, just before all the COVID stuff happened. And it was a great place to meet a lot of key people in industry, in government, and in academia. And we developed a lot of connections that have been useful for prospecting throughout the rest of 2020 and into this year. So things like that, where you pick the right industry, you get them at the right moment in time, and you make connections, and then referrals just start to happen naturally. That's been the most effective for us.
Great, excellent. Well, we would love to have a chance to tour sometime. It really is a fascinating place with lots and lots of pipes. It has its own railroad, correct, Tim? Or maybe a few different
Yeah,
railroads throughout?
we have 13 miles of rail within the site.
Yeah, really, really cool. All right, any audience questions for Tim about EBP or any of the industries within there? Great. Well, thank you, Tim, for that overview. It really is a fascinating place, and I think it's going to continue to play a really key part in our economy going forward. And we're about to hear from some of the companies that have made it a home, and how they're really driving innovation in their industries. So, Tim, please feel free to stay on and help us elucidate some of these. But I want to welcome some of our panelists that I see joining us. I see we have Max Richmond from Farther Farms. Welcome, Max. And let's see, we also, I think I did see Eric Otto as well.
Yeah, I'm here. Hi.
Hi, Eric from Greenlight. And then let's just check for our other panelists here. Is Kumar on? Yep, I see we have Kumar. Welcome,
Hello.
Kumar from
Hi.
Kodak Light Blocking. We're just hearing a little bit about that fascinating technology. And then our fourth panelist, let's see if we get all my windows up here.
I'm here.
All right, Andrew Fleming, excellent, from Li-Cycle. So welcome, guys. Thank you so much for joining us. We're going to dive right into our panel and our pre-planned questions, and of course give some time for our climbers to ask at the end. But welcome, thank you all so much for joining us. We're going to go ahead and give you each a chance to tell us a little bit about yourself and your organization. We'll go alphabetical by company. So we'll start with Max Richmond, VP of Business Development for Farther Farms.
Great, thank you so much. Nice to see all of you, meet all of you, and thank you so much for organizing, Shannon. I guess I would start with a quick question and ask how long, Tim, we need to be residents of Kodak before we're grandfathered into the official Kodak Zoom background. Unfortunately, my office doesn't quite offer the same aesthetic appeal at the moment. So let me give a quick kind of overview of Farther Farms. I'll do the best I can to contextualize the technology, where we are today, and our vision for the future, and what makes us so excited to show up to work every day. So just a quick overview of myself. I've been with Farther Farms since the summer of 2017, when we were 3 folks. Myself and our co-founder, Vipul Saran, who leads our technology development, and our CEO, Mike Annunziata, down at Cornell. And now 4 years later, we've gone from a lab scale setup to a commercial facility over here in Kodak. So it's been, as you can imagine, you know, in the startup land, a wild, exciting ride with a variety of kind of daily tasks, from the technology development we've done to microbiology work, to our kind of early marketing and sales and brand development conversations as well. So let me give a kind of a quick high level of Farther Farms, and then of course we'll have some questions, I think, at the end. So we are what we consider a food technology development company. So our charge is to develop what we call platform food processing technologies, akin to, say, canning or retort systems or HPP. You know, you go down the freezer aisle at the grocery store. Those we consider platform food processing technologies. They're fabulous because they can make food safely, relatively inexpensively, and of course in the quantity that can accommodate and build out a global supply chain. Our co-founder, Vipul, who I mentioned, is actually a 3rd-generation potato farmer from India, who back in 2014 and 2015 was doing some exporting of produce of local cooperative of Indian farmers, and transporting mostly actually to the Middle East, with the idea of opening some global markets to increase a little bit of the value that they were able to get for the produce. And the cost of refrigeration was so high. It's actually about 3 times the cost of the quantity of potatoes, that it was essentially unaffordable to use the cold storage. So you ship in ambient, and in that method, just kind of write off a 40 to 60% loss of the produce just because of spoilage. So he'd been doing that for a while and said, there's got to be a better way to approach the problem. And having a food technology background, he thought maybe there was a technological solution to how we can process foods. So that led us and Vipul to Cornell in early 2016, where he spent about a year developing the foundational carbon dioxide enabled processing technology that we've now moved up to Rochester. The way we contextualize it is, what we're trying to do essentially is take produce right now and foods, added value foods that currently require freezing and refrigeration, and we can convert those into shelf stability based on some nuances of the process, which I'm happy to get into to the extent that I can. So we see that element of taking, the cold, essentially bypassing the need for a cold storage chain to be both sustainable, right? I mean, we're reducing the energy reliance that we have. And the other interesting element is the accessibility angle, is opening new markets internationally that don't have the robust cold storage infrastructure that a country like the United States does. So our task has been to develop a foundational technical team and an operations team that can demonstrate the viability of the technology at scale. So the process for us was a pretty typical university technology track. So we started in the Cornell Food Science Department labs in Ithaca. We're there for about 3 years and scaled up the technology to a larger benchtop system, but recognized that given the scale and the focus on economics, of course, when it comes to food manufacturing, we needed to build out that technology ourselves at scale. So we were looking for places to do that. We found EBP, and I can touch on some of the reasons why we did. So the last 2.5 years, we built out a pilot facility in Eastman Business Park that can produce our first product, which is a never frozen French fry, taking a frozen supply chain product and converting it into shelf stability. Obviously, potatoes a big market. Vipul loves potatoes as a seed potato farmer. That's kind of his agricultural background. But also from a science perspective, by validating that the technology can work from a food safety perspective and a unit economic perspective on a commodity product like a potato, you've also unlocked the other possibilities for other products that we want to do down the road, say a guacamole that doesn't need to go brown, or converting hummus or fresh salsas from refrigeration to shelf stability. So in the landscape of food development, there's a lot of really, really interesting things going on. A lot of them you hear about Impossible Foods and Beyond Meat, two kind of buzzwordy names, but people know them well. A lot of focus on ingredients and formulations, and those are terrific. Appeal Sciences is doing some really interesting stuff on shelf life extension. So really a lot of fascinating stuff. I think the thing that is unique to our approach is that we look at the food system from a foundational processing technology, right? The reason we have a robust cold storage infrastructure is that we can freeze food really well. What if we could produce safe food in the quantity that we need at the cost that we need, in a new way that essentially allows you to transform the food system. So although we have grand visions, and we could certainly continue to get excited about that, where we are today is focused on just in the last 2 months being able to produce in our GMP facility a never frozen French fry product, begin to introduce it to the market as a validation of the product, because we can talk a lot about the technology, but it's got to be good food. It's got to be quality food. In our first case, it's got to be a delicious fry. So we're focused right now on consumer feedback, beginning to do our more product development and product improvement, and focusing on both kind of building out our technical team as well as our operations team, because of course we're producing day to day in our operations facility. So I did want to make sure that I touched on why we settled on EBP. And for us, there was really 3 reasons. Tim touched a little bit on the diversity and the diversity of business and industry here. And of course, the infrastructure is just incredible. So the first thing for us is, we scoured kind of upstate New York, from as far west as Buffalo and as far east as Syracuse and even beyond, looking for a place to relocate and to build out our pilot facility. The resources and the infrastructure here is so incredible that our approach was, hey, if we can come here, we can focus our resources and our technical know-how on exactly what is differentiating and important to us, which is our food technology. So moving into a place that already had the infrastructure just frankly made our lives a lot easier. We don't have to be the HVAC experts because Kodak has some folks here that we've been able to work closely on the utility side. So the infrastructure is just really, I mean, it's unparalleled. There's maybe 1 or 2 locations like this across the entire country. So for us, that was number one. The second piece, and I'm glad you got to hear from Tim before me, Tim and his team are just a fabulous group of folks. We've had a terrific time working with them. And the way they've set things up so perfectly for us is that there's just a clear alignment of interests and incentives, and being able to work hand in hand as partners with Kodak and Tim and his team has really been a differentiating experience for us. And then the third piece is, given that we're foundationally a technical team, we wanted to be in a place where we could attract the people, resources, and the knowledge base. That's, of course, central to who we are and what we're doing. So by being in Rochester, where, for us, we still have close access to Cornell, but, within the University of Rochester, within our IT, and actually we were talking about this last night, the concentration of technical talent for Rochester by virtue of the long history of Kodak is fabulous, whether it be the engineering firms we've worked with, or the people that we've been able to recruit locally. That talent base here, that community, the food presence, not only with New York State initiatives, but places like Pedestrian and Wegmans, there is a common kind of intellectual understanding and approach. So for those 3 reasons, the infrastructure, the team at Kodak, and the opportunity to attract people to Rochester and be in a place that is already a technical hub, for us, it just made all the sense in the world to be here, and of course to be able to stay in New York State and remain pretty close to our home base in Ithaca. So I think that's it for me. I hope I didn't go too much over. Thanks so much.
That's great. Thank you so much, Max. And this is a great, tie into an earlier program day that we had where we did speak with Cornell Ag Tech and some of the people that are down in the incubator. So it's awesome to see you guys growing to a level where you can really take advantage of EBP and thrive here. So thanks so much for sharing. And we will get back to you again with some additional questions. But next I want to go to Eric Otto and an update to his job, which is now VP of Manufacturing Plant Health for Greenlight Biosciences. So I'll turn it over to Eric to tell us more about himself and Greenlight.
Thanks, Shannon. Do you, I noticed I was trying to share screen, but I need permission.
Okay, let me make you a co-host and that should do it.
There we go. All right, let's see if this works. You guys see my screen?
Yep.
Excellent. Okay, so thanks, Shannon, and thanks everybody for the opportunity to tell you a little bit about what we're up to at Greenlight. Can you still see it okay?
Yep.
So a little bit about myself. So my name's Eric Otto. I've been with Greenlight for almost 2 years in June, and Greenlight's been around for about 10 years, but our focus probably started in the space of RNA probably about 4 years ago, or 2016 maybe. So, Greenlight's not biosciences, we're a biotech company, and we are an RNA company. And let me tell you a little bit more about this. So, our vision really is, as a biotech company in the RNA space, is to develop RNA for a variety of new applications. So it's been in the news a lot lately regarding COVID vaccines. There's 2 new types of vaccine in the human healthcare space. And so that's one thing you're hearing about RNA, and we're talking about the same thing today in RNA. And also in agriculture. So there's use cases of RNA in agriculture, and I'll be talking about that as well. And if you think about what we really bring to the table from Greenlight, is we have some fundamental platform technology of how to make RNA. We can make, and so there's a vast array of things to know when you're applying this, in a human health sense or from an agriculture sense. But we have those expertises, and we're building those expertises out. But we started as a core biotechnology company. And that's where we have our kind of patent landscape, all of our IP, and it's really a competitive edge that we have. So we want to, democratize the benefits of RNA, and there's really a world in need for both these human health challenges that we have, and also from a food safety perspective and food productivity. So, normally I'm talking to biotech people, so I just wanted to make sure that we all know what I'm talking about here. RNA, it's a biological polymer in every living cell. So it's very related, close cousin of DNA. Let's just go through this little picture here real quick. DNA is the purple stuff, right? So DNA is the equivalent in biotechnology, or the computer equivalent is the hard drive, right? All the information in cells is stored on the DNA, but RNA is sort of like a more mobile version of information. So DNA gets transcribed into RNA, and then RNA then goes and does a bunch of other things, including making proteins and other things. And this big yellow blob here is a catalyst. So in a nutshell, what Greenlight has done is we've developed a bunch of processes and technologies on how to make this red RNA molecule coming out of this enzyme. And not only do we make the RNA, but we make sort of a bunch of the components that you need in order to make it. And most of the science, there's a lot of science in every step, but there's a lot of science on picking what the DNA needs to look like in order to make the RNA. So this is kind of the technology platform that we're building. But not to, just to take it back a little bit, RNA is also a common item that is in every cell. It's used today. It's a food product. You can get, you can buy yeast RNA as a food ingredient. It adds that umami flavor to things. Oftentimes it's a major component of yeast extract. So that's another thing that when you look on a label, you'll see that. But if you make it the right way and under very specific under very specific conditions, it has biological function. And that's what we have expertise in, is making sure that our RNA has biological function when applied in the right circumstances. And the information that we have in this piece of RNA is giving instructions to things. So whether it's in the vaccine, it's instructing your body on how to make a protein that is going to help fight this virus that's infecting people. That's one kind of application. And then this other one I'll talk about in agriculture, where we're basically using it to influence what happens in insects. So that's our two major platforms. We're standing up these businesses in human health and in food security. And, it aligns to the megatrends of population growth and food security. So we're very excited about the opportunity to bring biotechnology, this new biotechnology, to a very large space. And to be a little bit more specific, and it'll get into the story of why we were relocated in Rochester. Our first set of products that we started with was looking at how we can use this in agriculture. And one of the gigantic needs out there is to help pollinating species. And if you look at the current agricultural landscape, the solutions that farmers have today and some of the solutions that they like, when they spray these pesticides, they kill all kinds of species simultaneously, including the good species, what we call the pollinating species, like bees. And so, we wanted to help that, and we're developing products for that space. Not only do we have products that I'll talk about for an insect called Colorado potato beetle, interestingly, but also we are developing products for bee health as well. So, these bees have a significant problem. They're the hive destruction. We're working on that as well, to how to help pollinating species. On the human health side, it's fascinating to watch this grow. We have vaccine programs for COVID, we're looking at COVID variants, all kinds of different permutations of this. We also have working on just standard influenza vaccines, and we're also looking at some other therapies. They fall into the camp of genetic therapies, RNA therapies, fascinating new things. And this is really all enabled from the last 15 years of core research on what's going on in RNA. A lot has been learned on how it works at the cellular level across many, many species. So I wanted to bring this example forward because this is the first product that we're bringing to market. It's an RNA, a double-stranded RNA product that is used to fight this invasive species called Colorado potato beetle. And it actually infects all over the Northeast, including New York State. And interestingly, we have done 4 years of field trials with this material. Our use rates are much less than standard pesticides, and additionally, the pesticides themselves. This is not. It's completely biodegradable. It's safe, really, to eat. The only thing that it really affects is this particular organism. Even other related species, it has very limited effect on other beetles, and it has no effect on other non-target organisms. So the problem that we're trying to solve here is this killing these insects that you can see here. This row used to look like this. These are potato plants before they flowered, and you can kind of see these twigs here. When this insect emerges, it just decimates these plants. And so farmers every year have to spray pesticides and coat the little potatoes with an insecticide so that it prevents this decimation. The interesting part of this story is that we've actually done field trials in using with the Cornell Ag Extension Group in Geneva, and it's out of the University of Cornell, and we did the trials here in Western New York near Sodus. So we've done trials at 30 locations all over the country, but there is actually agriculture extension groups here that has helped us with that. So a little bit about Greenlight and why Eastman Business Park. So just so you know that we have 3 locations. Our headquarters is in Medford, Massachusetts, where we focus on the biotechnology platform. We have our healthcare research and our preclinical and clinical development going on there. In Research Triangle Park, North Carolina, in Durham, we have our agriculture discovery group, which is focusing really on the application of RNA in agriculture. And so we have bioinformatics, entomology, plant pathology, all that kind of good stuff. Field trial teams, formulation and delivery, technology. And in Rochester, we're building out the team. In fact, these are the pictures from the facility where we are in building 350. Where we've just installed and are now commissioning and starting to use to sort of test. We're not in the use phase yet. We're still commissioning this pilot facility and production facility. We'll be able to make a metric ton or so of RNA, and it's kind of what we're looking at here: a series of tanks and fermenters and downstream processing equipment. And here you can see the inside of a fermenter. So here we're going to focus on manufacturing, supply chain, manufacturing technology, and all these types of activities. And it's very well suited to Eastman Business Park, maybe to answer that question about why we kind of came here. And I looked at these other 2 locations. We had already had a location in RTP and in Boston. And one of the main reasons that we came to Rochester was, one was the infrastructure. So what does the infrastructure buy you, right? It saves you some money. And for a startup company where every dollar really counts, we wanted to sort of limit the investment on the most important things. And if we can save on buying boilers and steam generators and stuff like that, then and chilled water facility, I mean, all those things, if you can purchase them as a service, it's a pretty big benefit. So that was one of the reasons. And I would say probably the biggest reason though was, we can do both our small scale stuff, our small scale work here, and we can grow here. And the time you can save by being able to do that at one location, as opposed to like the alternative when we were looking in Boston, we could have put in a 10,000 square foot facility in Boston, but then I have to find another facility where I'm going to produce, and then I have to have another location. So being able to do that in 3 locations instead of 4 is a big benefit, and the time that we're going to be able to save by doing our Eastman Business Park is another big saver. So we're looking at, we have 10 people today. We're still hiring. We're going to be like 30 people probably in a couple of years as we expand, and we're looking forward to going through that process as we commercialize our products. Yeah, so I think I hit all the questions that you had asked, Shannon. So I'll stop there and hand it back to you.
Excellent. Thank you so much, Eric. A lot of science and clearly innovation going on there. So thanks so much for sharing. All right, we will go next to Kumar, Sri Kumar. If I mispronounced your name, Kumar, please correct me. But he is general manager of Kodak Light Blocking, exciting new division over there. And I'll turn it over to him to tell us more.
Yes. So thank you for giving us an opportunity to address you. Um, Kodak and light are almost synonymous. So, we've been dealing with light for over 130 years now, but this particular development is a little off the beaten track. It doesn't have anything directly to do with photography. What it is we have, back in the day when we were doing a lot of different film formulations, we developed specific coating materials and layers for variety of uses within the film. And from that, we developed techniques for suspension polymerization, which a lot of it was developed right here in Kodak Park. At that time, it was called Kodak Park, Building 59, as well as here in Building 82, 83 complex, inside EBP now. And out of that suspension polymerization technique, we developed a specific type of small particle that can scatter light. So that doesn't sound like a wondrous invention, but the fact of the matter for this particular invention is that the scattering of light happens because there are features that are engineered inside the particle. The particle size itself is in the microns, and the features that are inside are in the nanometer scale. Now it turns out that by varying those features, we can address pretty much the wavelength of light that we need to scatter. So we can scatter visible light. So what I mean by scattering visible light is that normally, if you want to block light coming in, you put a drape, and when you go to the hotel room, for instance, you pull in this blackout curtain, and that completely blocks the light. Now that's blocking light by basically adding opacity. It's a carbon layer that is coated inside the drape that is blocking the light completely. But if you have a scattering layer on the curtain, depending on how you engineer it, with 100% of the scattering, you would scatter off any radiation that falls on it. So the inside of the room will be dark still. But without the use of carbon and without the use of any other coating aids and such other things that you need to disperse carbon and make it stable and not crack and so on and so forth. So the first application that we developed for it was, in fact, to make just visually opaque materials, just the same as these blackout curtains. And they have just been developed and has been branded as Coda Lux. So you'll probably see that very soon inside in a hospitality environment. For instance, in hotels, big chains, potentially like Hilton and Marriott and the like. And we already have in Kodak the plant that can be modified, and actually built up a little bit to make these particles with the features in them. What we did not have is a good place where we could coat it. So for textile uses, the capital of the textile industry in the United States is basically, it's south of the Mason-Dixon line. It's North and South Carolinas, anywhere from, you mentioned Durham, all the way through Charlotte to Spartanburg and beyond, and some areas in Atlanta. So we've been there coating this material and making it available to our customers. It's a small startup business. So just as you mentioned, you have 10 people in Greenlight. We have about 10 people in the small startup, but it's a little bit of a different environment because, the Kodak Light Blocking subsidiary is a small subsidiary within a large company. And we, of course, have the benefit of using Kodak's facilities and certainly Kodak's brand. And so some of it helps us a lot, because of the fact that we don't have, like you said, we don't have to invest a lot ourselves. We can just pick up the phone and call somebody and get some great resources to come in and do the stuff for us. Part of it is also a problem for us, or a burden, because when you start up something new in a big company, the customer's expectation of a Kodak product is very high. I mean, high quality. Kodak stands for high quality. So they are not going to cut us. There is no give here. The first day on which we offer the product it has got to have fantastic performance and quality. So that sort of a situation was hard for me to imagine doing at a toll coater or somewhere outside of this area. So much of the inherent technology for the product is right here. The knowledge base is here. The people are here. The scientists who discovered this materials, as well as the engineers who developed these processes. And it also provides us with excellent analytical facilities, right here in Kodak. And as some of you mentioned, we also have a great academically nurtured environment here with all the universities, as well as small startup companies and the like. So there is a possibility here for us to grow. So we proposed to Kodak that we would like to start a fair-sized textile coating station here. It's a different kind of coating from the film coatings, but Kodak has a lot of expertise in all different types of coatings. This is a process called foam coating. So basically, it is a way by which you make a foam and apply it on a material. And the reason to do that usually is because if you want to precisely apply a little bit of material over a large surface, it's very hard to meter that properly without substantial volume. So one thing the foam does is produce a lot of volume of material for very low concentration in it. And you can uniformly apply the foam, so that gives you, when it all is dried out and processed and finished, a very fine layer of particles on the fabric with a very cost-effective and robust method. So that plant is going in Building 319, which is right next to your plant in 350, Greenlight's plant. So you'll start seeing some construction work going on there, and the plant coming up. Some of the exciting aspects of this work is that, I told you earlier that depending on the features in the material, we can tune it to scatter a given wavelength of light. Of course, the interest for the hospitality industry is simply visible wavelengths. Like I said, in the hotel room, all you're trying to do is to make the inside of the room black. But when you look at applications for the US military or such other applications, when you say that you can scatter ultraviolet or you can scatter infrared, either in the near IR or in the mid IR, not so much in the far, there is now all sorts of other interests that come in. So there is a potential for us to be using this facility here for more than just consumer use as well. So for that reason, again, it had to be in a secure environment. And naturally, we couldn't find anything more secure than this place right here. So that's where we are. And like I said, I appreciate a chance to associate face with a company name, and I'm sure we'll run into each other as we work here. And if you have any questions, I can answer it. Thank you very much for your time.
Absolutely. Thank you, Kumar. Yeah, you guys are actually getting a chance to meet some of your neighbors that might not have been possible. Awesome. Thank you so much.
It's an exciting environment. First off, it's so exciting to, personally for me, some of you, I mean, you guys probably weren't born when I joined Kodak. So I've been in Kodak 40 years. So I've seen Kodak at its heyday. And I've worked with Kodak, me along with some other people here, like Terry Tabor, who's my boss. Uh, we've seen Kodak through the ups and downs, and so we guys, some of us are essentially sort of Kodak romantics at heart, because we remember those times, and we remember and we understand the strength of this place, the academic strength, the strengths in technology, like small particles, like optics, like coatings, and the like. And to be able to say that after so many years, Kodak is putting a coating plant in this place, it is so exciting. It just is wonderful for us. So I feel very good about it, and we are privileged to work with a team like you, of fantastic new ideas right here in Kodak.
Awesome. And Rochester is lucky to have someone like you helping Kodak stay relevant and progressive. So thank you so much for sharing.
Thank you.
All right. So we'll go lastly for just an overview to Andrew Fleming of Li-Cycle. And I'll turn it over to you, Andrew.
Thank you. I guess first off, it is nice to meet some of the other tenants here in Kodak. And I will say, Eric, I've seen the stainless steel through the wall. Color me green because it is beautiful. So again, Andrew Fleming, plant manager here at Li-Cycle. I've been in electronics manufacturing and OEM material handling for the majority of my career, and actually personally felt the need for this industry about 3 years ago with some AGV lithium-ion battery packs that would come back from end of life cycle or premature failure, and there really wasn't much of an industry to capture that value stream, that waste stream. Previously, what the world would do with these lithium-ion batteries, from the one in your phone that's right next to you, I'm sure, to some of the EVs that are out there, is they'd go off overseas, they'd be exported and run through a smelter. And truly the only things that were captured were the nickel and the cobalt because of the process. Thermal, they're burning it off, the electrolyte, the lithium, graphite, manganese, plastics, everything else is expelled and non-recovered. Well, Ajay Kochar and Tim Johnston, our co-founders, saw this as a rising problem. Both of them were in the lithium mining industry and saw that this was something that was going to come to a head, and actually developed the process on how to reclaim those battery materials from the lithium-ion batteries. So what do we do here in Spoke 2 in Rochester? We take lithium-ion batteries, regardless if they're from consumer grade, low voltage, so your DeWalt drill batteries, your cell phone batteries, up to EV modules, and actually process them into 3 different recyclable value streams. So through a wet technology, we're able to separate out the low density plastics, which are recycled, the metal foils, so your copper, aluminum, et cetera, that goes out to another metals recycler. And then what we really are after is that intermediary material, which is black mass. That contains that lithium, cobalt, nickel, manganese, graphite. And that is what we do here in the Spoke, is we develop that intermediary material. So what the future holds for the intermediary material is Li-Cycle itself will refine that intermediary material into battery grade chemicals. So what we're able to do is, as most of you can likely understand, is that mining is very exhaustive on the ecosystem. So what we're able to do is take that once looked at as a waste value stream and actually turn it into a production and reintegrate that back into the manufacturers. So this material would then be sold back to battery manufacturers, truly closing the loop on that. So with material recovery rates over 95%, we are able to reduce the amount of of material that needs to be mined, that ends up getting burnt off and not reclaimed, and that there's a ton of value that's been added in these materials that are just being burnt off. So what Li-Cycle does is we're able to recover that and reintroduce that back into the manufacturing realm. So I'm sure everyone sees everything's going to lithium ion technology. Electric vehicle sales are they're supposed to, they're looking at moving, I think, 26 million EV sales by 2030. Most of us watched the Super Bowl. I'm sure you saw Will Ferrell in his electric vehicle commercial. It is the way of the future. Everything is going to a greener technology, something better, more sustainable. And this is a key component in that, to make it more sustainable by having it recyclable and truly extending the usable lifespan of that material almost indefinitely. So really exciting stuff going on over here at Li-Cycle. Just a couple of things as to, why Rochester, why Eastman Business Park. Hearing the three folks that went before me, I'm sure you can all guess number one. Existing infrastructure. There it is. Yes, absolutely. Again, one of the core things for Li-Cycle is recycling. We're able to find a facility that was not being utilized and recycle it into something that we can use. The existing infrastructure here at Eastman Business Park, between primarily was in this area was chemical manufacturing. We have that infrastructure built in. We have that. We have the steam. We have glycol. We have the electric. Everything's already built in, and in that infrastructure, we were able to, believe it or not, place our entire system in 31 days. Our entire machine that does this, we had it flown in through the wall on the second floor on I think it was November 3rd, and by December 4th, we were running trial material. I mean, it's incredible, and the folks here at Kodak, this wouldn't be possible without you guys. Absolutely. So the support there from the Kodak side has been fantastic. A couple of other reasons that we chose Rochester was the historically industrial area. There's always been an industrial aspect to Rochester, which has a large group of very skilled people, from skilled machine operators to engineers with RIT, U of R. It's a great opportunity to really build an all-star team because we have fantastic talent in the area. The third reason that we chose Rochester is looking at what we do. So we take that battery material and then we refine it. So where are we getting that battery material is we're placing these spokes in areas that generate them, large areas of people. So if you only have, a few people, you're only going to get a few cell phone batteries. But if you have a large metropolitan area that can service the entire Northeast, you have a larger area where you can take that material and bring it into our process. So.
Great, that's fascinating, and it's so cool to hear the sustainability aspect of it. I know that's really an important area these days.
Yeah, absolutely. And the really neat thing is we're able to do it with zero waste.
Wow.
Yeah. So all of our the liquid in the system is actually kept within the system. We don't have any waste. It's kind of wild when you think about it.
Yeah.
So.
I don't know what the feasibility of this is, but you have to think that there is so much of these materials in landfills. I mean, does the future hold, mining landfills? Is that even something that could be done?
I don't know. Potentially. I mean, obviously we want to keep this stuff out of landfills. But there's so much of it that's already in the world, that's already been mined, that people have done the work to pull the lithium, cobalt, nickel out of the ground. And it's out there. It's in that manufactured or semi-manufactured or getting ready to be demanufactured stage.
Mm-hmm.
We're not going to lasso an asteroid of lithium. It is a finite resource. So what we're able to do is just, again, reutilize what we're using. So.
Yeah, that's great. Excellent. Well, thanks so much for sharing. I want to circle back around for our last planned question here. So going back to Max, What does the future hold for your industry and organization? What do you see as being the next frontier, and how are you guys preparing for that?
Sure. Thanks for the question. I will concentrate this to what the future holds for Farther Farms. I would say there's really three things that we're focused on right now. As I mentioned, the last 2 months is the first time where we've been able to make a product and sell it out into market to restaurants and distributors and put it in people's hands, which is a major inflection point. So there's three phases for us that we're going to continue to grow throughout 2021 and beyond. The first phase is increasing our production capacity here at Kodak. And actually, I'm right around the corner from everybody. We're at building 318, so just right across the street. So you really did corner this part of the park. So yeah, first is increasing production capacity. We want to get the product into the hands of more people. We want to do some shipping internationally, just to say that we can and kind of spread the word and get more and more customer feedback. That involves team expansion. We're 25 now. Could potentially get up to 50, by building out the manufacturing side by the end of 2021. That's kind of number one, the shortest term plan. Number two is intermediate to long, but really a core component of what we're doing is expanding our R&D efforts, so that we're starting with a potato product. So that means making a different SKU. We do a shoestring fry right now. What if somebody wants a steak cut fry? So there's some kind of simple product development to expand what we can do on the potato side. The other piece of that is using those kind of foundational learnings that are associated with our first product to start to spin off into more foundational R&D and diversify our product exposure. Again, we talked a little bit about some other fruit and vegetable products. There's potentially some interesting applications in dairy or semi-solid foods or liquid foods, which would require its own engineering component. So given kind of our foundational validation of the way that core science and technology scales, we now get to layer on top of that the engineering and the food science and the microbiology work that'll help us further expand that. And the third piece is taking what we've learned here in Rochester and our pilot facility and our research center and spinning that off on an intentional manufacturing direction. So we can make a French fry here in Rochester. That's great. Now we can take that and potentially partner with some interesting strategics in the US or around the world to build dedicated French fry manufacturing facilities, which could be in New York State, it could be in England, it could be in Ireland. So this home in Rochester allows us to validate technology, develop products that then could have their own commercialization life cycles where that production is done elsewhere. So that's kind of the short term, the medium term, and the long term plan for us, with the understanding that all of those kind of weave together depending on the direction that we're able to go.
Great, thanks so much. I'd love to hear that Rochester is a center for innovation that's going to influence lots of other areas. Excellent, thank you. All right. We will go next back to Eric. What does the future hold for RNA?
So RNA, very interesting, very relevant for everybody. In fact, I encourage people to go look up some of the, if you haven't looked into the vaccine technologies that you're hearing about in the news from Moderna or Pfizer with the technology provided by BioNTech. Go look at the Journal of American Medical Association, the really interesting videos and stuff on it. So, it's really burgeoning in the pharma space. It's going to be there for a very long time. It has some strategic advantages, and there'll be more pharma companies coming to that space. It solves, by you going to making RNA directly, it solves a bunch of problems. And it kind of allows you access to things directly to that one facet of biology that's difficult to do through other delivery vectors. So and human health, that's going to spill over to animal health as well. So there'll be applications of using mRNA medical treatments, vaccines, and for animals. And then this third leg that we have in agriculture is it's brand new from an industrialization perspective. And for me, one of the reasons I joined Greenlight, because I look at this as the next, 30 years of large-scale biotechnology development. You know, I come from a background in I've been working for 25 years in biotechnology and a lot of enzymes and pathway engineering, and we made a lot of different types of products from cells, from microorganisms. And RNA, because of the fundamental understanding of the cell biology that's going on for all these various species, it allows us this application of this technology. And so I still consider that is going to be burgeoning for quite a while, and from an industry perspective. So we're really kind of at a new space that we're adding to biotechnology, kind of the way enzymes was in the 90s when I started. And then from a Greenlight perspective, there's very few companies kind of looking at all this holistically. In fact, I don't think there are any. There's a few of the big ag companies, and of course there's on the pharma side, but there's not really that many that have started by doing both of them. So that's kind of unique about Greenlight. And like I said, its foundation is in the kind of core production technology, and that's why we kind of ended up the way that we are, and we'll continue to grow in all three of these areas. But immediately for us, we're going to focus on agriculture in Rochester. We're looking for space for our manufacturing of our vaccines and medical therapies. We've rented some space in Boston area. It's really tough to get CGMP facility, but that's something that we're in the middle of for CGMP space for our human health, but on the agriculture side, the plant health, we're going to do that here in Rochester. With the facility that we're building, that we have built. And we're going to start, like I said, we'll be able to make about a metric ton of material. And, we're hopefully in a few years, we'll get to 50 tons through probably 3 products. And we can use the same asset base to make just all kinds of different products, because it's a core foundational technology platform to make the RNA, and then it can be applied to many different products, many different species, et cetera. So we'll want to get to 50 tons, 100 tons, and we'll have to see how it grows. But right now, we think we'll be able to do that here in Eastman Business Park. Yeah, so maybe that's any clarifying questions, or did I kind of ramble down there?
Oh, no, that's great. Yeah, absolutely. We'll open it up for audience questions when we get to the end here. But I want to go to Kumar. The future. You mentioned some of the military applications. What else is the future hold for Kodak light blocking?
Well, I think the immediate future here is just making sure that the plant comes up and we staff it, run it, and get it into full production mode over the next year or so. And so one of the focal areas of expansion here would be along that line, coated products, both for consumer use, commercial use, industrial, technical, and strategic applications. So that would be one arena of expansion of activities for us. The other is that the active material that goes into this radiation or light scattering property has these features in it, as I told you. And so if you think of a small particle with features in it, like lots of pores or other things, there's a lot of different other uses for it, such as they can be designed to be small microreactors. One could think of controlled drug release using some of these particles, and especially our way of making it and the chemistries lend themselves to a wide variety of materials to be made into that morphology. So these other applications of particles are also things that we would pursue. Maybe not all of it would be right here in EBP, because it could be with some partner companies and the like. So you can imagine our expansion in 2 different vectors, one along the direction we have now charted out, towards this particular application and product, and the other to go back to the technology and make it available to a broader variety of solutions out there in the field. So that's probably the way in which this would develop in the next 4 years.
Great. Thank you so much. All right, Andrew, last but not least, future for the industry and for LASIK.
Well, future for the industry is huge. Again, referencing back is the growth of lithium-ion technology and utilization throughout the world. Really looking like it's going to take over the transport industry. Aerospace. There's huge upside, and it doesn't look like it's slowing down. The industry is growing, and again, it's a finite resource that we want to make the most of, and it's good for the earth. I mean, we're not running that typical fossil fuel level energy consumption. So, and then as far as life cycle goes and its growth pattern, I mean, with our spoke here, we're going to be in the next few months have the full 24/7 capabilities. And then shortly thereafter, we're going to be putting the hub right here in Rochester. So our first commercial hub, we have our demo hub in Kingston, Ontario, but our first commercial hub where we will be extracting those battery grade chemicals out will be right here in Rochester. So that should be on the horizon. And then you look at the like a 5-year growth plan, or we're looking at 20 spokes throughout the world. Again, these are very easily deployable. We can put them in small process areas that consolidate that battery material where it's being generated, and also the plan for 3 more hubs worldwide. So a lot of growth here at Li-Cycle.
Very cool. Very exciting. Awesome. Well, thank you guys so much for sharing so much and answering those questions. I want to go ahead and open it up to our climbers here in our last moments if they have any specific questions about your company or the industry or the technology. Any climbers out there with questions? I know we've covered a lot. We've covered a lot. I have some things to Google. I need to know more about some of these technologies because a little over my head, but that's great. That's why we have the experts running the show.
You can hit me up on LinkedIn too if you guys ever want to get a hold of me too.
Excellent. Thank you, Eric.
I want to see that. Yeah. That stainless. Beautiful.
Okay. Come on over.
Good deal.
Tomorrow.
Awesome. All right. Any last call for questions? Farah's got one for Max. After potatoes, what vegetable or fruit do you think is next? Obviously, potatoes are very popular, but what could be the next big thing?
It's a great question. Well, I know the question came via chat, but I would actually turn it back and say, what do you think we should do? But the way that we analyze it is from first a food safety perspective and then a market perspective. So part of the virtue of starting with potatoes is that it's a huge market, given that we want to be increasing sustainability. The more we can convert to shelf stability from a frozen supply chain, the better. So from my standpoint, from a sustainability angle, from a food justice angle, first targeting, the larger market segments is really interesting. Of course, the exercise is balancing that with, the technology and the business considerations of farther farms. And, we want to be here for a long time. So how do we check, the boxes of economic viability, technological viability, and market viability? So I would say, yes, avocados are a fabulous. I think I can see a note here. Avocados are one that we've talked about a lot, and people have had a real interest in. So we could definitely start in that frame. Right now, I can say that we're focused on, after the potato, maybe hummus, salsas, and guacamole are kind of the three biggest ones that come to mind. Although other people certainly have other ideas for how we can continue to expand R&D. So no. I would say focused on the potato right now because we don't want to get over our skis. Our motto is under promise, over deliver. So for, if word gets out around this conversation, we're just focused on the potato for now, and hopefully we'll surprise you with something new in the next few months.
Max, are you guys going to do all the development, or are you going to license this technology?
Great question. We're exploring a couple of different models. Ultimately, the IP and the know-how and the engineering development work and the microbiology food safety development work has to be housed within farther farms. The way we start to bring that out into the world could run the gamut between manufacturing facilities we run ourselves, licensing models, or potentially, you know, JV situations where we're working on with some strategic partners where someone could bring, say, a raw sourcing and marketing expertise, and we could drop down our technology. So there's definitely a few different models that we could pursue, and none of them couldn't be done in tandem with the others.
Excellent. Thanks so much. All right. Any final questions before we thank our panelists and let them get back to their busy lives and businesses? Well, Max, Eric, Kumar, Andrew, thank you so much for joining us. Tim, really appreciate giving us the context and the setup of EBP, and really wish you guys the best of luck. And we look forward to seeing your names more in the news and where the future will take you. So really appreciate it, and best wishes.
Thank you.
Thanks a lot.
Thank you so much.
Thank you.
Same to you, Shannon. Bye-bye.
Bye-bye. All right, climbers. Well, that is the end of our abbreviated morning session. We are going to be circling back around. I should have a final date and time for you just a little bit later. It doesn't look like we're going to have everyone available all at once, but we'll absolutely be recording the sessions. Most important thing is definitely the interactivity of Andrew's session, but we will capture all of the learnings and takeaways from our optics, photonics, and imaging when we dive into that. Like some of you may have heard, there was a congressional caucus hosted by Joe Morelli that was scheduled for today. So that unfortunately took away all of our speakers. So we will definitely be circling back. That's another fascinating topic with lots of technical info to absorb. So hope you guys enjoy the rest of your day, and we look forward to talking to you soon. Bye.